A man launches a boat from point A on a bank of a straight river, 3 kilometers wide. All right. So I need to draw a river. Let's use the blue highlighter for the river. This is one edge of the river. This is the other edge of the river. You can label it river. That looks ugly. I can't have that. Sorry. Don't do this in pen. And then they tell us that this river is 3 kilometers wide. So we could put a 3 kilometers like this. Okay. He launches his boat from point A on the bank. So let's say here's point A. He wants to reach a point B 8 kilometers downstream on the opposite bank. So let me draw a little perpendicular here. Then I want to go about 8 kilometers down. This kilometers here is 8. So the distance from here to here is 8 kilometers. This is downstream, so that means the water is flowing this way. Any questions so far? Oh, sorry, Christy. I tell you what, I'll make it up to you. I'll just post these notes to Canvas, so then you can copy them on your own time all over again. Any questions so far? So let's read the next sentence. The next sentence says, he could row his boat directly across the river to point C and then run to point B, or he could row directly to B, or he could row to some point D between C and B and run to B. Okay. Let's try to understand this. I'm trying to think about how I can draw this without ruining stuff like your picture. So I'm going to shrink this down. I'm going to create the 3 scenarios that they talk about. So here's one, let's copy that guy. Here's another, let's copy that guy. Here's the 3rd scenario. Let's copy that guy like this. Okay. And they said that the point C is directly across. So I forgot to label the point C before I copied. So here's C, here's C, here's C, and here's C. That's directly across the river, right? So let's try to illustrate each of these situations. So the first situation he says is, he could row his boat directly across the river to point C and then run to B. So in that scenario, he sort of rows his boat this way, and then he runs this way. That's the first scenario that they were talking about. What's the second scenario that they're talking about here? They're saying he could row directly to B. So if he rows directly to B, that means it looks something like this. And then the third scenario is, or you could row to some point D in between B and C. At this point, I realized I forgot to label B. And then they said that D is somewhere in between. So let's put D right here, somewhere between. So he could row his boat part way, and then he could run the rest of the way. So they're sort of proposing these 3 different situations. Does this make sense to you? So this is the scenario that we're trying to create here. Okay. So I just want you to understand the scenarios. So let's a good thing I'm gonna post these notes for Christy, otherwise I'd feel bad for moving everything around like this. But I need more room to finish this problem, so I can't have these drawings taking up all the space. All right. So they say, if he can row 6 kilometers per hour and run 8 kilometers per hour, where should he land to reach B as soon as possible? We assume that the speed of water is negligible compared to the speed at which the man rows. All right, fine. So I think what we need to do is we need to label our picture a little bit. Okay. So why don't we introduce a generic D somewhere in here? And let's draw a line that connects those two. Let's give this a variable. Let's call this variable here X. And then we need another variable to sort of represent the distance. So why don't we call the distance they're sort of running along? So why don't we call the distance from C to D, why don't we call that distance Y? Okay. Then if I label these two variables over here like this, what does this 6 kilometers per hour and this run 8 kilometers per hour represent? What is the 6 kilometers? I'm looking for D something, D something. Well, I'll tell you the other something, it's DT. Right, you can think of this as dx dt. Actually, you know what, sorry, I don't want to do that for this problem. When I do it like that, it makes it look like a related rates problem. So let's not worry about that yet, even though for related rates, you do want to do that. I just want to keep going because I want to at least get to the function that we're trying to minimize or maximize. So what is it that we're trying to minimize or maximize? Does anybody want to tell me? What are we trying to minimize? Well, it says as soon as possible, right? So when I see as soon as possible, we're trying to minimize time. Exactly. So what's the time going to be? The time is going to be equal to the rowing time plus the running time. And I want to use this fact that distance is equal to rate times time. So if I solve for time, that means time is equal to distance over the rate. So I know that I asked you earlier about that 6 kilometers per hour and the 8 kilometers per hour. I got ahead of myself because when I realized that I want to minimize time, I want to use this time is equal to distance divided by the rate to do that. So in our case, what's the rowing time going to be? Well, the rowing time is going to be the distance the person rows, which is X, divided by the rowing speed, which is 6. When I want to get the running time, what's the distance that they're going to run? What's the distance from here to here? That's right. That's 8 minus y. And we're going to divide that by 8 because that's the rate at which the person runs. Okay. So we'll write one more thing and then we'll stop for today. So we've already labeled our picture. We've got the variables. We know what we want to minimize. I have a function time that depends on two variables, x and y. And I don't like that. I want to write it in terms of one variable. So there must be some sort of constraint, some piece of information that I haven't used yet that I need to use. Does anybody know what it is that I have not used yet? That's right, Alice. I have not used the fact that the river is 3 kilometers wide. So if I knew that I had this picture, well, hey, you put too much pressure on me. I can't draw anymore. I lost my skills. And this side is x, and this side is y, and this side is 3. What's the relationship between these guys? You can just give the relationship a name if you want to. That's right. This is Pythagorean theorem. So we know that x squared is equal to 9 plus y squared. Okay. So this means that x is equal to the square root of 9 plus y squared. So in the end, we're going to get that our time in terms of y is going to be square root of 9 plus y squared over 6 plus 8 minus y over 8. Okay, so we're going to finish this next time, but I hope you can see that I've made an error. I called the function t of x, but my independent variable is y actually, so I should change that to a t of y. So we're going to do everything with y as being the independent variable. Okay. Okay, so now we got to do the calculus stuff. So let me write this a little bit nicer. I could write this as 1 over 6, 9 plus y squared to the 1/2 power plus 1 minus y over 8. Okay. And then I want to calculate the derivative. So when I calculate the derivative, what rule do I need to use for this first part here? Good. Excellent. So we need a chain rule. That's 1 over 12. You're going to have a 9 plus y squared to the negative 1/2 times the derivative of the inside. So that's times 2y. And then the derivative of 1 is just 0. And the derivative of negative y over 8 is just minus 1 over 8. Okay. So I can write that a little bit nicer. I hope you guys can see that the 2 and the 12 can sort of, 2 over 12 can simplify to 1 over 6. So if I write this a little bit nicer, I can have a y on top, and I'll have a 6 times the square root of 9 plus y squared minus 1 over 8. Okay. And then what I want to do is I want to find the critical values. So to find the critical values, I'm going to set this guy equal to 0. So So we set the derivative equal to 0. We're going to get 0 is equal to y over 6 times the square root of 9 plus y squared minus 1 over 8. That's going to give us 1 over 8 is equal to y over 6 square root of 9 plus y squared. That's going to give us 6 square root of 9 plus y squared is equal to 8y. I should maybe pause here to make sure no one has any questions yet. Does anyone have any questions so far? Did I forget a y? Not this time. Not this time, I think. Okay. So let me move that. Let me come up here. So then what do we get? We're going to get I could divide both sides by 2, right? Is that worth writing down? I guess so. So we'll get a 3 square root of 9 plus y squared is equal to 4y. And then I think I should square both sides because I want to get rid of that square root. So when I square both sides, I'm going to get 9 times, hold on a second. Okay, all right, we're good. So I square both sides. Maybe I should come in here, square both sides. And then what are you going to get? You're going to get 9 plus y squared is equal to 16y squared. Okay. So we need to distribute. So you're going to get a 81 plus 9y squared is equal to 16y squared. You can subtract 9y squared from both sides. We get 18 is equal to 7y squared. And then this tells us that y squared is equal to 81 over 7, which tells us that y is equal to the square root of plus or minus 81 over 7. So we don't allow negative time, right? So this really means that y is equal to, the square root of 81 is 9, so this is 9 over rad 7. This will be our critical value. That's not my final answer, but it's a critical value. Any questions about this? Okay, so remember, we are trying to minimize time. And in this particular case, what does y represent? Y represents sort of how far along this shore we land the boat. We row to. So this is really a closed interval question, because if I row all the way across, then the whole distance here is going to be the whole distance is 8. If I row directly to point B, then the distance you run is 0. So we really want to sort of consider all 3 of those cases. So we need to calculate what's T of 0? And if you punch that into your calculator, you're going to get 1.5 hours. Sorry. We're going to calculate what T of that critical value was, which is 9 over rad 7. And when you do that, you're going to get something of close to 1.33 hours. And then if you row directly across shore, that's T of 8. Sorry, yeah, that's when you row directly across the lake. So you have to run the full 8 miles. That's going to be also 1.5 hours. So since we're trying to minimize time, we want to choose the smallest of these guys. And the smallest of these is this one. So this is the minimum. Guess I didn't say this already. You're definitely allowed to use a calculator for this test.